All right, so today we're going to take a look at what's called a dot product, and we'll look at a few applications of what can you use the dot product for. All right, so what I've written here is two vectors. Okay, I've written them in unit vector notation. Vector V has a horizontal and a vertical component. I call the horizontal component A1 and the vertical component B1. I've got a second vector, and it also has a horizontal and vertical component, which I've called A2 and B2. Now, the reason I need two vectors is because I'm going to multiply. If I want to multiply, by definition, you need two things in order to multiply together. Okay, A1, B1, A2, and B2, those would all just be numbers. Okay, so if we were doing a real problem, it might be like 5i plus 6j and 2i plus 12j. Okay, they would all be numbers. Okay, and the way you find the dot product, it's a very simple calculation. First, this is how you write it, v dot w. And you do have to write it that way. I know sometimes in math, when you want to multiply two things, you just put them next to each other, and that means multiply. You can't do that here. Does anybody know why? I can't just put this on paper. If you did, that means nothing. Nobody would understand that. If, people that are looking at vectors, they'd have no idea what you mean when you write that. Anybody know why? Okay, the reason is because multiplication, you can do it two different ways. One way you can do things is called a dot product. The other way you can do them is called a cross product. Okay, cross product is not something we can do because it only exists in 3D. Okay, you can't do a cross product in 2D. But it is important when you're talking about vectors in general, people assume it could be 3D. You have to either put the dot, and then they know, okay, we're doing a dot product, or put the cross, like the little X, and then we know we're doing a cross product. All right, so just make sure you put V dot W, and pronounce it that way too. Okay. Okay, so the dot product, very simply, is just A1 times A2 plus B1 times B2. So you're multiplying the horizontal components, you're multiplying the vertical components separate, and then you're adding the result. So I said earlier, A1, A2, all those are just numbers. So what do you get if you multiply a number times a number? You get a number. And here you have a number times a number, so that's a number. And then what's a number plus another number? It's another number. So that means when you find the dot product, your answer is it's a number. Okay, like 10, 15. Okay, it's just a single number by itself. What does that number mean? Well, I'll show you after. All right, so let's find the dot product between V and W. Okay, so I want to find V dot W. So we're going to multiply together two things, two other things, and then add them up. Okay, Rebecca, what's going to be the first number that I put in parentheses? 2. Yep, 2. And Selenia, how about the second number?
5.
Yep. So you're going to multiply the two numbers in front of I, plus now do the two numbers in front of j. If it's a negative, use the negative. Negative 3 times 3. Okay, Kate, what's 2 times 5? 10. And negative 3 times 3 is negative 9. So what's the dot product here? 1. So V dot W is 1. Finding a dot product by itself isn't really that hard. Some of the applications, like what does that actually do, get a little harder. Okay, but dot product is a very easy calculation. Before I do this, very quick initial thoughts. Anyone think they know what the difference is going to be between v dot w and w dot v? Negative one, so that's a good idea. That sometimes things switch the order. Your vectors get the opposite. Any other thoughts? What could happen? Same thing. All right. If it's the same thing, we have a word for that. Does anyone remember the word when you switch, when you multiply, it comes out the same? Associative is when you change the grouping, but that's another one we've talked about. Commutative. So if this comes out to 1, then that means the dot product is commutative. Okay. What would change in the first two sets of parentheses if I do w dot v? It would be 5 and 2, not 2 and 5. 5 and 2. And then in the second set, what would I put in there? Katrina? Yeah, you do w first. 3 times negative 3. Now, what am I going to get when I do that? I get the same thing. So switching the order that I multiplied those two vectors in, at least for a dot product, comes out the same. Okay, so what that implies is that the dot product is commutative. Now, until we get to 3D, we're not talking about a cross product today. But I will tell you the cross product is not commutative. If I did V cross W, it doesn't come out the same as W cross V. It has the idea that Shakira mentioned. You end up getting the opposite. Okay, but cross product is totally different. All right, let's find V dot V. Okay, so we're going to basically dot a vector with itself, V dot V. So let me scroll back up in case we need to see V again. How would I do V dot V? What times what plus what times what? Well, Nick, what do you think?
2 times 5.
Now careful, we're just using
2
V.
times negative 3.
Not quite. Think of it, maybe if it helps, that's one vector. That's the other vector. So, do you see now what two you'd multiply together?
No.
Not sure? Anybody help out, Kyle?
2 times 2.
Yeah, multiply your I components. 2 times 2 plus,
3 times
and then negative 3 times negative 3. Okay, so that's V dot V. 2 times 2 plus negative 3 times negative 3. Okay, what do I get if I do that?
13.
Yeah, we get 4 plus 9, which is 13. And now let's do W dot W. And then I want to see if you notice something with V dot V and W dot W. Okay, Jared, what would be my calculation for W dot W?
5 times 5.
Yeah. Perfect. 5 times 5 plus 3 times 3. Okay, and if I do that out, I get 25 plus 9, which is 34. Now, you can look at either V dot V or W dot W, but I'm going to look at W dot W. Does anybody recognize what this 34 almost is? It's something we talked about yesterday, but it's missing one thing. Right? Well, let's look at how we got the 34. What did we do with the number 5? We times it by itself, and what's another name for that? We squared it. And then what did we do with the 3? We squared it. So we squared two things, and then we added them up. What formula did we do something very similar to that yesterday, but there's one thing here that's missing? Yeah? Yep, and what did we use the Pythagorean theorem for? To find the what of a vector? Yeah? The magnitude. So dotting a vector with itself almost gives you the magnitude. The only thing it's missing is the square root, right? Because you square the first number, you square the second number, you add them up. But the only thing you don't do in a dot product is you don't take the square root. All right. So basically, what that means is if you dot a vector with itself, you don't get the magnitude of the vector. You get the magnitude of the vector squared. Dotting a vector with itself gives you the magnitude of the vector squared because you didn't take the square root. Okay, so not a super important idea, but it's just a fact that, that comes up. All right, let's try this one. Okay, Nolan, what do you think my dot product is going to be here?
2.
Yeah, 2 times 0,
0.
and then 6 times 0. So what's my dot product?
0. That's 0.
Yep, which is 0. Now, before I go on, is this 0 a number, or is this 0 a vector? We just did a dot product. So what kind of answer did I say you always get? It's a number. Okay, that is the number 0. The vector 0 is right here. Okay. That's the vector 0. Okay, a bold 0. That's the number 0. Any questions on the difference between those two? Okay, so the dot product, it is distributive. Okay, just like you're used to using the distributive property with regular multiplication, you can do it with a dot product. You can do u dot v plus u dot w. Okay, and remember, I'm saying dot because if I say times, that's confusing. Times in vector means nothing because we don't know what kind of times do you want to do, dot product or cross product. So u dot v plus u dot w. All right, so where the dot product comes in handy is if you want to find the angle between two vectors. Right, so if I had a vector that went like that, and another one that goes like that, and I want to know the angle in between them. The dot product is one of the things that is helpful to get that. It's not the only thing you have to find, but it is one of the things that you need. All right, so if you want to find the angle between two vectors, okay, I'm not going to go through the proof of the formula. It's not too hard, but I'd rather you save brain power for the word problem. Let's not use it up on this formula. So the formula says the cosine of the angle equals the dot product over the product of the magnitudes. So in order to find the angle between two vectors, there's 3 things you've got to figure out. 1, the dot product. 2, the length of your first vector. 3, the length of your second vector. You need all 3 of those values. And then you just fill them in. Okay? And we're going to use our calculator to solve for theta. Now we've got a cosine with the theta. So when we get to solving one of these, hopefully we remember how to cancel out cosine. Okay, we don't have to say it yet, but there's something you can do on each side that's the opposite of cosine. Okay, and we're going to need that here. Okay, so any questions on the formula? It's the dot product over the product of the magnitudes. Okay, does everybody have the formula? All right, so I have these two vectors, and I want to find the angle between them. Okay, first, let me just sketch them. So maybe we can get an idea, or maybe estimate what we think the angle should be. I've got 4i minus 3j. So I'm going to start right there for both of them. So the first one was 4i, and then minus 3j. So that's my first vector. And what was the second one? 2 and 5? Yeah. 2 and 5. All right, so then I'm going to go right 2, up 5. That's my second vector. All right, so if you had to estimate that angle, how many degrees do you think it is between those two vectors, roughly? How much? Yeah, I'd say it's a little more than 90, maybe 95, 100, somewhere right around there. Okay? So we'll go through, we'll find the angle, and then see if that's what we get. Okay, so 3 things we need. We need the dot product, we need the length of u, and then the length of v. Okay, so let's start with our dot product. Karen, can you tell me the first 2 things I'm going to multiply together to get my dot product?
4 times 2.
Yep, 4 times 2. And Paige, can you give me the next 2 things?
Negative 3 and 5.
Negative 3 and 5. So that's 8 minus 15. Okay, so Jesse, if I do 8 minus 15, that gives me a dot product of, yeah. So there's my dot product. All right. Now I need the length of u. I'm going to start, I put my square root so I don't forget it. And Katrina, can you tell me how I'm going to find the magnitude of u? So these 2 numbers, you don't need them again. Those were just for the dot product. We won't use those to find the length of u. To do that, all you need is the 2 numbers that were originally part of u. Yes. Good. 4 squared plus negative 3 squared. Okay, so that's going to give me 16 plus 9, which is the square root of 25, which means my vector is how long? 5. Okay, so that's the second thing I need. And the third thing is the length of v. Wait, Sam, can you tell me how I get the length of v and then simplify it?
2 squared plus 5 squared equals 25 plus 4 square root of 29.
Yep, square root of 29. And now, as far as reducing that, like let's say it came out to square root of 20. Technically, you can reduce it, but I don't really care if you reduce it because that's not a final answer. Those 3 things are just going to get plugged into this formula, and that is my final answer. Okay? So don't worry about reducing anything. All right, so the cosine of my angle equals the dot product divided by the product of the magnitudes. Now, as far as doing this out, I don't care what this is. Don't even waste time doing this out. But I do have to do something now to get theta by itself. Okay? So I've got cosine theta. How do I get rid of cosine? Yeah, take the inverse cosine of what's on the left, and take the inverse cosine of everything that's on the right. Type that into the calculator, and then you'll have your answer for the angle between the two vectors. And remember, we're hoping it's around 95 or 100, okay, a little more than 90. So I'm going to do it in degrees. I'm already in degrees. So second inverse cosine. And you can type it all in at once as long as you're careful with your parentheses. I'm going to put the entire denominator in parentheses just like that. So -7 divided by 5 square root 29. And we get about what we thought. Okay, an angle a little bigger than 90. 105.1 degrees. Okay, that's it. That's our angle between the two vectors. Any idea when that would be handy to know? Why you'd want to know an angle between two vectors? No? All right, I'll show you why in a little bit. So sometimes when you find the angle between two vectors, you can have two special cases. If the vectors come out with an angle of 90 between them, okay, that means they're perpendicular. But what they usually do with vectors is instead of saying that the vectors are perpendicular, they say that they're orthogonal. Okay, why they use that word, I don't know, just to confuse you. All right, so orthogonal means that vectors are perpendicular. It just means the angle between them is 90. Now, there's a shortcut to finding if two vectors are orthogonal. Okay? You don't have to go through the whole formula. So I'll come back to this in a second. But if two vectors are orthogonal, it means perpendicular. And what's the angle if two things are perpendicular? 90. So I'm going to take my formula. I'm going to fill in the angle because I already know it would have to be 90. And then I'd have some fraction on the other side. I'd have something in the top, something in the bottom. Well, let's see what would happen if they were perpendicular. Let's take the cosine of 90. You get 0. So if they're perpendicular, this fraction would have to equal 0. What's the only way that a fraction can equal 0? Yeah? If it's 0 on the top. Now, what's in the top when you're finding the angle between two vectors? What's in the top of that formula? The dot product. So basically, the shortcut here is if the dot product comes out to 0, then your two vectors are perpendicular. Okay? And that's all you have to do. Because if they come out to 0, 0 divided by anything is 0. And if this fraction is equal to 0, I guarantee you that angle has to be 90. Okay, so that's a shortcut for finding if two vectors are perpendicular. The dot product is 0. Okay, so let's just figure out if these two vectors are perpendicular. If they're not, it doesn't ask you to find the angle. It just says, are they perpendicular? Yes or no? Okay, let's find the dot product. And how about Brianna? Can you give me my calculation for the dot product?
2 times 1.
Yeah. 2 times 1. And then if you want to put that in, it's 1 times 2. What does that come out to? 4. So are these vectors perpendicular? No. Dot product didn't come out to 0, you don't even need to do anything else. That's it. So those vectors are not perpendicular. If you made any one of these numbers a negative, then they would be. Like if you make that a negative, now I have negative 2 plus 2. Okay. You can put a negative in any one spot that you want, and then they would be perpendicular. Right. Now, if two vectors are parallel, okay, that's the other special case you can have. You could have two vectors that do this. What's the angle between those two vectors? 0, okay, because they're right on top of each other. That's one way you could have parallel vectors. Or you could have this. Those vectors are also parallel. If you wanted, you could just move it up there. Now you can see it's parallel. What angle is it between the red and the black one on the other side? It's 180. Okay, so if you get an angle of 0 or 180, then you have parallel vectors. Now let's see if we can come up with the same kind of shortcut. Okay, let's start with the case where the angle is 0. Let's fill that in for our angle. You'd have some dot product on the top, product of the magnitudes on the bottom. Okay, let's take the cosine of 0. I get 1. How can a fraction equal 1? What has to happen? Yep?
It's the same on the top and bottom.
If it's the same on the top and the bottom. So notice what he just said involved both parts of the fraction. So you can't, it's not like the last time where all you got to do is look at the top. If a fraction's equal to 1, it just has to come out the same on the top and the bottom. So there's no shortcut there. You got to do the top and the bottom. Let's look what happens if the angle was 180. Okay, you'd have something on the top, something on the bottom, depends on the problem. Let's find the cosine of 180. -1. Okay, so same question. When can a fraction equal -1? Well, Eric? Do you know when would a fraction come out to -1? It's almost like what Kyle just said. Tell you what, give me a problem when I divide the two numbers, the answer is -1. Anything you want. Yeah, just give me a division problem that comes out to -1. Okay, give me another one. Sure. Do you notice anything about your numerator and denominator in both of those problems? Is there a relationship between those two numbers?
The denominator is always positive.
Well, I mean, you could do it this way too. It doesn't always have to be positive.
Well, one's positive and one's negative.
Yeah, they're opposites. Okay, so in order to have vectors that have an angle of 180 degrees between them, the top and the bottom have to be opposites. Okay? So if you get the top and the bottom the same, they're parallel. If you get the top and the bottom opposites, parallel. If you get the top 0, perpendicular. If you get anything other than what I just said, then it's like the first problem. Just it's a random angle between the vectors. All right, so let's see if these two vectors are parallel. So I'll start with my dot product. Skylar, what's 4 times 20? 80 plus, what's -5 times -25?
25.
25.
25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25.
Yep, 125. If I add up 80 and 125, I get 205. Okay, that's the dot product. Now let's find the length of V. John, how do I get the length of V?
4 squared plus -5 squared.
And what's 16 plus 25?
41.
41. Length of V. And we need the length of W. Dan, what's the length of W?
20 squared
Okay.
plus 25 squared.
Which gives me the square root of
1025.
1025. All right, so I don't need to use inverse cosine here. Okay, if all I'm checking for is if they're parallel, I want to know if the top comes out either the same as the bottom or the opposite. Well, they're not going to come out opposite. The top is positive, the bottom is positive. I already know that. So they're either going to come out the same and be parallel, or they're going to come out different and then just be some random angle that's not parallel. All right, so let's see what it comes out to. Let's take the magnitude of V times the magnitude of W, and you know what? I'm going to write it with parentheses. So I'm just taking magnitude V times magnitude W. Okay, that's the denominator that I'm trying to see if it comes out the same as 205. Okay, so square root 41 times square root 1025. You know what, let's use the graphing calculator. So it's square root of 41 times square root 1025. And it comes out to 205. So what does that mean? These vectors are parallel. You have the same value in the top and in the bottom of the formula. So the question, determine if these vectors are parallel. Yes, they are parallel. Okay, any questions on that? I think that's a good place to stop today. Okay, so on 352, I want you to do 7 through 17 odd. Okay, each question has 3 parts. Okay, the 3 parts are like what we were doing in class. Find the dot product, find the length of U, find the length of V. And find the angle. So they're all related anyway. You've got to do all 3 things to find the angle. Right? And then I think it also asks you, say if the vectors are parallel, perpendicular, or neither. And once you find the angle, that's very easy to say. Okay, so you've got about 15 minutes. So I'm going to give you time to start that. So if you need some books, I'll get those out. But please use the time to start working on that.